Thank you for watching my video. My name is Astrid Krasniqi. Now we will talk about CCNA Semester 2 Day 1, but this is Part 2. On this section, in Part 2, Introduction to Switch Network, we talk about preparing for basic switch management. Then we talk about Duplex Communication. We will move on to conversation configuring switch port at the physical layer. Then the new feature Auto-MDIX. Then we talk about verifying the switch port configuration, the commands that we should run to verify the port configuration. Then SSH Operation, we configure that. But then we talk about port security and configuring dynamic port security. Then we'll move on to Network Time Protocol. Okay, Introduction to Switch Network, Part 2. So preparing for basic switch management. To remotely manage a Cisco switch, it must be configured to access the network. So the switch must have an IP address and a subnet mask must be configured. Without that information, we cannot configure the switch, or we cannot manage the switch remotely. We always have to be going right next to the switch with the console cable. So for us to be able to remotely manage it, the switch has to have an IP address and a subnet mask. If you want to manage the switch from a remote network from somewhere else, then the switch has to have a gateway, default gateway configured as well. The IP information, address, subnet mask and gateway has to be assigned to a switch virtual interface, SVI. Well, not the gateway, just the address and the subnet mask. We have to assign it to the switched virtual interface. Gateway, we do it in the global mode. Although these IP settings allow remote management and remote access to the switch, they do not allow the switch to route layer 3 packets. So the switch is still layer 2, doesn't understand IP or routing, it's just got one IP address for you to be able to manage it. It's like a PC, it's got one IP address for you to be able to manage it. Okay, so I will do a demonstration where I have a router already configured. It's connected to a switch. Well, on the right here, it's got a crossover cable connected to this PC here. Then it's going to connect to the switch, and is connected to a switch is connected to another PC. Now the network where the switch is connected to is 192.168.1.0/24. That's a network ID. The PC is .10. For example, 192.168.1.10/24. The PC is connected to the switch in FA05. The switch is connected to the router in FA01, and the router, this address FA01 is .1, so 192.168.1.1. We're going to configure the switch to have a VLAN 1, so switched virtual interface, so the virtual interface is VLAN 1, and that VLAN is going to have an IP address .50, ending with .50. This side is FA00, I should say here, FA00. No, this is FA00, this is FA01. .1 here, 10.1.1.1.0, that's the network ID. So all the configuration is done on this side, except that we're going to configure the switch. Okay, let me just change. Okay, this one, change it to 0, since it's 0. Okay. Okay, so what we're gonna do, we're gonna configure the remote management on SVI VLAN 1 with an IP address 192.168.1.50/24 and gateway 192.168.1.1 and test it. Okay, so I've got already configured here a network. So what I'm gonna do is the router is already configured, the PC is already configured. So what I want to configure is only the switch. So I'll click on the switch, I'm in the configuration. What I like to do is do the configuration in Notepad, and then we can paste it on the switch. Okay, so I'm going to do the configuration in the Notepad. So first thing that I need to do is type enable, then configure terminal. Then after that, I'll make a separation a little bit so I know like which sections of the command I'm doing. So first I'm going to give a name, so host name SW1 for example, or S1 I think I called it. So no IP domain lookup, service password encryption. If you don't know what these commands do, please have a look at some previous videos I've done. CCNA semester 1, day 1 or day 2 I think it is. So service password encryption, no IP domain, enable password Cisco, enable secret class. Okay, these are some of the commands on the global configuration mode. Then I'll go to the console mode. So console 0 is our first console, password Cisco, login, the 2 G's, sync, and then exec timeout 00. I'll move on to the next console, the VTY lines. So next line, VTY 0 to 4, 5 lines. Well, for the switch there's a 15 lines. So password Cisco, login. I'll do exit and a banner, MOTD, authorized users only. And I'll end the banner with the same mark. I'll do end, and let me just move this so we can all see it. End, and then copy running config to startup config. Okay, so what I'm going to do, I'm going to highlight all of this information, right click, copy, go to my switch, enable, and paste. I have to check if there's been any errors. No, I type enable there, configure terminal, enter configuration command, 1 per line. Hostname S1, yep, that's fine, no IP domain lookup. So it seems like there hasn't been any errors, which is great news. Okay, so to see what his configuration you already have, is show running config. Now even if I restart this switch, this configuration will be there because I did save it. So I did say copy running configuration, whatever I'm running, to the startup configuration, which means if I reload this switch, this configuration will still be there. Okay, now show running config is going to display you what you're running at the moment, not what you have saved, it's just what is running. You can see the password is encrypted, even the clear text password, because of this command. This is the secret password or MD5 password, which is already encrypted. We don't have to do that to do anything to have that. Okay, that information is done. We have configured it. Next thing we're gonna do for the remote management. Now for the remote management, I have to go to the global config mode, and then after that access the virtual interface. So interface, now virtual is VLAN 1 for example, it's there by default. Now this, you can go to different VLAN. Now it's suggested that you choose a different VLAN for the management. For example 99. It doesn't mean that you have to use 99, but different than 155 for example. Okay, so in this exercise I'm going to do it in VLAN 1 because it's already there. Give an IP address, interface VLAN 1, that's a virtual interface. Physical, it would be FA01 for example. But if I do it on physical, because this is layer 2 switch, it's not going to work. It's going to give me an error. So I have to do it in virtual. So VLAN 1, virtual local area network 1. Give an IP address. So IP address was 192.168.1.50 with a mask, 24-bit mask. So there you go. That's our 24-bit mask. We have to remember to do no shutdown to bring the interface up, or the virtual interface up. I have to do exit, go from the interface configuration mode and type the gateway. So IP default gateway 192.168.1.1. That's the router's IP address. Okay, copy all that and go to the switch and paste it. Now there was a problem there. As you can see, you have to pay attention to these commands. Okay, I did misspell that, so that caused the main problem, which cascaded it from other problems as well. So you have to pay attention to the marker. Okay, fine. I can see on this my banner is working, so I can type Cisco here, enable class. These are the two passwords that you should be always using while you're training for the Cisco, so you don't get tempted to use really complicated passwords. Configure terminal, then I'll go there. I can delete that because that was wrong, that was a problem was making it. I already done that. Now highlight all this, copy and paste it there. Okay, now I don't see any markers like we saw early on. Here are these markers. I'm not seeing anyone here. So this is good. It's telling me the network, the configuration is good. Plus, it's telling me the interface VLAN 1 has changed the state to up, so it's working. Change state to up. Excellent. And I can ping it. Or first, let me just do show IP interface brief. Now, FA01 is already connected. That's towards the router. And FA05, that's towards the switch, towards the PC is connected. But this is my virtual interface. It's got an IP address and it's layer 1 is up and layer 2 status is up. So that's great. Okay, so if I try and ping my gateway, so ping 192.168.1.1, and you should see a reply. Okay, now that dot there, it didn't work, so it timed out. That is doing its thing. So its resolution is finding the MAC address and IP address. Now after it did that, then we have a full exclamation mark, which means a success. So 80%. We lost 1, but we got 4. Right. If we do it anymore again, if we do it again, now ARP doesn't have to go through, so it's always going to be 100%. Okay. Next thing I'm going to try and ping the PC. The IP address of the PC is 192.168.1.10. I can go to the packet tracer and have a look. Yeah, .10 is there. So I'm going to try and ping the PC. Again, what I'm expecting is to lose 1, which is true, and I got all 4 because the ARP did this thing. Okay, so if I ping it again, I get 100%. Right, now if I'm in the local network, this is my local network here, the yellow section, I should be able to telnet from the PC to the switch here. So I go to the PC, open the desktop here, then open the command prompt and type telnet, and the IP address of the switch, so 192.168.1.50. Since I see their open authorization open, the section is open, and I can see authorization users, that's my banner, authorized users only, users access verification. I need to type the password, which was Cisco here. Okay, I mistyped it, so Cisco again. That was correct. As you can see, the password, it doesn't show what I'm typing. I'm typing lots of characters, weird characters, nothing for the security reasons. We can't see the characters. This was class. So now I'm inside the switch, so show run, I can see the information inside the switch. When I'm done, I type exit, I'm back to my PC. Excellent. But this is a local management. Now we want remote management, which means from another PC on the remote network. Now this PC is on the network 10.1.1.0, which means it's on a different network. So I open that PC, I go to command prompt and do ipconfig. Yes, it's true, it's on a different network. So what I'm going to do first, I'm going to ping the switch. So ping 192.168.1.50. Always try and ping it to see that there is a configuration. There is a communication between the two devices. It's true. I got reply from the switch, so there is a communication. I have sent an echo request and I got an echo reply. So excellent. I can communicate with the switch. The next thing I'm going to do, try to telnet. So telnet 192.168.1.50. Again, I can see similar information to what I saw on the PC1. Open is trying authorized users only. I see that my banner, and is asking, is challenge me with password. So password is Cisco enable class. Now this password here, this password is what is asking is for this password, for the VTY lines password. So if I put a different kind of password here, is gonna ask for different passwords. So the first password is the VTY lines. The second challenge that I'm getting is for this enable secret, this class here. Okay, we just did remote manage the switch from this PC2 here. So if I go again on the PC2, I can see that I'm inside the switch now, and show IP interface brief. Again, we can see similar information, VLAN 1, that's the IP address of VLAN 1. Excellent. So when I'm done, I type exit to log out from the switch. Now duplex communication, remember there was a half duplex communication where one device can send or receive. It can't do both at the same time. It can't send and receive at the same time. It's like talkie-walkie. Well, one is actually speaking and the other one is listening. They can't speak at the same time both. Another type is full duplex. This is like a mobile phone conversation or the phone conversation where everybody can talk at any time. So send data and receive data simultaneously. To configure the switch ports at the physical layer, we have to go to the layer of the port, inside the port, and then start configuring something. So for example, I'm not going to write these in the notepad because they are written here so you can see them. First, you go to the global configuration mode. Then you enter the interface configuration mode. In there, you can type different interface duplex, different speed, and here I want to show you the Auto-MDIX as well. We can save the configuration for the to the startup config. Okay, so I'm going to go to the switch here. Now I'm in the switch. So I type configure terminal. Okay, I will go to one of the ports. So interface FA02. There's nothing connected to FA02. I want to see the commands that are available, especially on the packet tracer. So first of all is the duplex. This command, duplex configure duplex operation. Auto, that's a default auto configuration, auto duplex configuration. Full will mean that you are forcing it to be in a full duplex, send and receive at the same time. Or half, you are forcing it to be in half duplex. These are the three options. We have auto, which is going to negotiate with the other side to find out the best, if it's the other side can support full or half. Well, they will try and attempt with a full always. The second command is speed. What speed we're going to run. Obviously this switch can support 10 Mbps or 100 Mbps. Now that's the Ethernet speed, the fast Ethernet speed. Some of the switches they will be able to support 1000 Mbps as well, or even more. Auto, again, same as with the duplex, auto is going to negotiate with the other side what speed is the best to run, or what's the highest speed that they can run. Okay, so I would leave these two, duplex into auto and speed into auto if you can. Okay, the next thing we need to do, we talk about Auto-MDIX features. Now you remember, switch to switch, what cable do we need to connect it with? Well, it was a crossover cables, because these two are similar devices. So anytime you connect two similar devices, you need a crossover cable. So router to router, similar device, crossover cable. PC to router. Now this is considered similar device because the router is considered a specialized PC, and the PC, for example, can do the routing as well. All you have to do is install a server and then install the routing feature, and there you go, it's a router. PC to PC, well, easy, similar device, so it's a crossover cable. When we connect switch to the router, two dissimilar devices, so that will be a straight through cable. Switch to the PC, straight through cable. PC to the server, straight through cable, and so on. Now all of this you can forget about. As far as the switch is concerned, we have this great new feature, which is Auto-MDIX feature. With Auto-MDIX, you don't have to worry about the straight through or crossover. Whatever cable you connect the two switches with, if this feature is on, it's gonna fix the option. It's gonna fix the cable for you. Well, it's gonna set the ports up to accept the cable you have connected. So if I go to my switch here, for example, the next section is auto. Well, it starts with MDIX, yeah, MDIX auto. So auto enables automatic MDIX crossover detection on this interface. Till late it didn't support this, the packet tracer didn't support this, but now it's supporting it. So it's a great new feature added to the packet tracer. So certain cable types, straight through or crossover, were historically required when connecting devices. This is what MDIX stands for. Automatic Medium Dependent Interface Crossover feature eliminates this problem. The next thing we need to know is the different commands. First command is show interface. Displays interface status and configuration. So if I go to the switch, to do the show commands you have to go to the privilege mode. So end and then show interface, and then type what interface you want. So show interface FA01, for example. There's quite a lot of information here that we see. First of all, we see the line is up, is working. So the layer 1 information is up. Line protocol is up, so it's good. That's layer 1 status and layer 2 status. The MAC address for this, the bandwidth that we are using, the delay, what encapsulation mode that we are using, and the keep alives that we have. Plus we can see some of the errors here, if we have any errors, input errors, for example output buffers failures and so on. Show startup configuration, we're just gonna display what configuration you have on the switch if you reload the switch. Then displays the current configuration, show running configuration, or show running config, I should say. To display what's on flash, well, show flash. That will display the iOS and any other file that you have stored in flash. Display the status hardware and software status, show version. What commands you have entered on the what commands are in history, show history. For example, let's see what our commands are in the history. Show history. Okay, we did type this, enable, conf t, show IP interface brief. We did ping a few times, configure terminal, show interface FA01, and then show history. Show IP, and then interface ID, displays IP information about the interface. And then show MAC address table. What is the MAC address table? So show MAC address table. So you can see that this switch has learned on port FA01 dynamically the MAC address of the PC. SSH operation, or secure shell operation. Now, secure shell is a protocol that provides a secure encrypted command line based connection to a remote device. Now you have to think, if I don't have SSH or secure shell, what do I have? Well, you have telnet. Telnet is clear text. Every information that you send in telnet is clear text. SSH is commonly used in a Unix based system. The Cisco iOS software also supports SSH, which is a great thing. And a version of the iOS software including cryptographic encrypted features and capabilities is required to enable SSH on Catalyst 2960 switches. So some of the iOS, they need to support this cryptographic encryption features. If they don't, you cannot enable SSH. The reason is, to support the cryptographic is because we need to create the key or the certificate. Because of its strong encryption features, SSH should replace the telnet for management connection. So always should remotely manage to the switch or the router using SSH in production. While we're doing a test on the learning, it's okay, telnet is fine, small network and so on. In the production, in real life, in real world, always SSH. SSH, you have to remember, it's a reliable protocol, which is TCP port 20 by default. And telnet is a reliable protocol as well, it uses TCP port 23. To configure the SSH, we have to go to the global configuration mode, create a domain name, generate a key, give a username, and then go to the VTY and do the transport input SSH. Okay, we're gonna configure one slowly. What we're gonna do the next, we're gonna configure SSH. So, okay, to configure SSH, let me just put a separation here. The first thing that you need to do, you need to change the host name. Well, not change, but change it from the default. We already changed the host name, so host name S1. That's good enough. The default is switch. That's not good. Switch is not good. It's not gonna like it. You can't create the keys just by the default name. So you change the host name. Host name S1. That's good enough. The next thing we need to do is change the. I'll give it domain name. So IP domain name CCNA.com. Okay, that's the. The next thing we have to do is create a cryptographic keys. So crypto key generate RSA. Crypto key generate RSA. This is gonna start generating. It's gonna ask us like this. Do you want your keys to be 512 bits on size? Now if it says anything on the brackets, it's recommending you this. If you agree, you don't have to type 512. All you have to do is press enter and you agree with it. So what I'm gonna do is I'm gonna copy this information and paste it on the switch. So copy, go to the switch, go to the global mode, config T, and paste it there. RSA, yeah. So 512. Now you see that was a false fire alarm out there. Okay, so host name, we changed the host name to S1. Then we created a domain name ccna.com. This is, we just creating this name. Then we created the keys, crypto key generate RSA, and it's asking us, do you want 512 bits? How many bits in the modules? 512? Yeah, we agree. We hit enter. That's it. Our keys are being generated. So if I go to here, just change this to RSA. Okay. Next thing we're gonna do is create a username who's gonna log on, a user who's gonna log on to this switch. The first thing we need to do is create a database, a local database. So user name, for example, admin. When admin logs onto the switch, we want the admin to get a privilege 15. So privilege 15 and password Cisco. Okay, so now when the admin user tries to log on to this router, it's going to get privilege 15. So let me just copy this and paste it on the switch and see if there's errors. Okay, username admin, privilege 15, password Cisco. Great, there hasn't been any errors there. Right, move back in to the notepad. So I created my username, admin, created the privilege 15, password Cisco. The next thing I need to do is go to the VTY lines, because this is for remote connection. So line, not console, you have to go to VTY 0 to 15 and say login local. So next time with this command, what I'm doing, I'm saying to log in, use the password. It has to be coming from the local database, which is this. And the next, transport input SSH. With this command, what I'm saying, anything that comes trying to remote connect to this switch, I want it to use only SSH, not to telnet. Okay, so I'm going to copy all this to the switch as well. Excellent. All that configuration is done. So what we did, we generated the domain name cisco.com, for example. Then we created a domain name. That's just, in the real life we would use our domain. We created the keys, encryption keys, and then we created the local database. Username admin, we give it privilege 15. Transport input, we said that only SSH is allowed, and to use the local database when you log in. Okay, so now this switch is ready to accept any SSH connection. Now if I go to the PC2, so this was here the PC2. So if I go to PC2, early, as you can see there, I was on the telnet. So I did telnet, this is this IP address, and I was in. So let me just try that again. So telnet 192.168.1.50. Now you can see this says no, closed by foreign host, so it's not working. The next thing I need to do is SSH -L. So for login, I will use admin and then the IP address. So 192.168.1.50. I'm not using the telnet protocol now. I'm using the SSH, and I'm logging on L admin, the name admin, and then the IP address. Press enter. You can see that it's open and it's giving me password. I don't see the banner because I'm at the privilege 15. So banner password is Cisco. After I press the password, now I can see the banner. It says authorized users only, and now I'm in the switch. So as you can see now, I'm inside the switch, but all this configuration is through SSH, not telnet, which means that if anybody is capturing our packets, will not be able to make sense of those because they will be encrypted. Okay, we did the demonstration. We did configure a secure shell on the switch and then test it. That you can access with secure shell. Security. Now with the secure unused ports, all the ports they are unused, or the switch hasn't got any end device connected to it, secure them by shutting them down. Port security. Port security limits the number of valid MAC addresses allowed on a port. So it limits the number of valid MAC addresses. For example, if one cubicle has one PC in it, you want to enable only one MAC address to be allowed on that port. The MAC address of legitimate device are allowed access, while other MAC addresses are denied. So your PC at the cubicle is allowed to go to the rest of the network. If that cubicle user brings his laptop or another device, that will be denied. Any additional attempt to connection by unknown MAC addresses will generate a security violation. Secure MAC addresses can be configured in a number of ways. So first of all, we can statically secure the MAC addresses, we can dynamically secure MAC addresses through the server, or we can use something called sticky secure MAC addresses. What sticky does is the first MAC address or the first PC with a MAC address that sends the data is considered to be the allowed MAC address. Okay, the first violation mode is protect. With the protect, when the maximum numbers of MAC addresses has reached the limit, the port will be blocked. Those MAC addresses will still be able to communicate, but there will be no more MAC addresses allowed on that port. Now there will not be any notification sent to the administrator. The second one is restrict. Same thing as the protect, but there will be a notification sent to the administrator. The last one, which is the default, if the violation has occurred, the port will go to shutdown mode. So on this demonstration, I will show you how to create a port security on this port, FA05, and then test it by connecting another device on that port. To bring the port back from the error disabled state, we need to shut down that port and bring it up. Okay, so let's go to the packet tracer and see what we're going to do. On this board, we're going to enable port security. Now this PC is fine, as long as you can go and ping, go to the network and so on. When I connect a different PC, it can be with the same IP address, the switch will disable that port or will shut it down. Okay, so the first thing I need to do I'm gonna still do it on Notepad. I have to access the port, so interface FA05. Now, first thing you need to tell the switch that this port is going to be a PC connected to it, never going to be a switch connected. So switch port mode access. What this does, this command, it says, okay, at this port there will be an end device connected to it, not a switch, for example. So the second command will be switch port security. This command will enable the port security. Without this command, the other commands will not work. Let me just test these commands. Configure interface FA05 switch port mode access. Switch port port security. Now you have to actually write this command, switch port port security, and the rest of the commands they start with that. So switch port port security maximum. How many MAC addresses there will be a maximum? So what you're gonna say 1. Maximum is 1. So switch port port security MAC address. So what MAC address? We're gonna say sticky. The first MAC address that comes in, that's gonna be a allowed MAC address. The next command is switch port port security, and then violation shutdown. Okay, I'm gonna copy all these commands and paste them and just see that there's no any errors. So make some space here and paste it there. Excellent. There hasn't been any errors, otherwise there will be a marker somewhere. We said interface FA05 switch port mode access. We are telling it that it's gonna be an end device, and then we're saying a switch port port security. Switch port port security maximum 1. We allow only 1 MAC address to be enabled. Switch port port security MAC address sticky. The first MAC address that comes in is allowed MAC address. And then switch port port security violation. If there's a violation, I want to bring the port in the shutdown mode. Okay, I want to do a spanning tree port fast. So this command, what it's going to do is going to save us 50 seconds when something happens for the port to go up, to go green. This is automatically going to switch it to the green. Okay, this command, I don't want you to pay attention right now, as this will be covered on the spanning tree lessons. Excellent. Okay, now what I'm going to do is I'm going to go to this PC and ping this PC. See that we have a connection there. Okay, so first thing is ipconfig. And say ping 10.1.1.10. I think is the other PCs. Okay, excellent. I just got a reply from the other PC, so everything seems to be working. On the switch, if I go press it, just type and show port security, and see show port security. Okay, port security, we have it on FA05 1. And if the violation will be shut down, and say show port security interface FA05. Now with this, what I see is the port security, it is enabled. The status of the port is secure up. Violation will be shut down if there's a violation, and on top of it I have a last source address, so I have a MAC address here. Okay, so what I'm going to do again, go to the PC, change the PC. We did ping it, so everything was working fine. This PC can ping. So what I'm going to do is add another PC, well, say laptop here, and this laptop I'm going to give it same IP address as a PC, so it's going to be 192.168.1.10. default subnet mask 192.168.1.1. That's the IP address of the gateway. Excellent, done. So what I'm going to do now is going to swap these ports from this genuine PC to this attacker PC. So grab that port and stick it on the attacker. Now when the attacker PC starts sending some data, this port should be going green. Sorry, red. I should say. Okay, I'll go to command prompt and I'll try and ping something. So ping 192.168.1.1. That's my gateway. As you can see, right away it's gone red because the port security is enabled. So this is not going to work. We can wait here for a long time, but there's always going to be a request timeout. Okay, so to bring that onto the green, first we have to go to the switch and say access that interface. So interface FA05 shut down, and then no shutdown. Okay, if you go back, the port is still red, so we need to change it actually. So change it here because it's still. So I'm gonna grab it, put it on the correct PC. Access the switch again. So interface FA05 shut down first, and then no shutdown. Minimize this. The port is gone to green. This PC, let's see if we can ping. So I'm gonna ping my gateway. So 192.168.1.1. Yep, I can ping the gateway. Can I ping the other PC? Yeah, I can ping the second PC. So this PC is fine. All the data is fine. If I unplug it, plug the laptop, now it's green until the laptop is trying to send something. So if I go to laptop and try and send something, so ping the other PC 10.1.1.10, now it's going green, red again. Okay, that shows you the port security. It's very useful for all the legitimate devices. They should be able to work on them, but not the attackers. Network time protocol. Network time protocol, or NTP, it's used to synchronize the clocks of the computer system data networks. NTP can get the correct time from the internal or external time source. With time sources can be local master clock, some devices holding the master clock on the internet. There's a servers on the internet, they held the master clock, or atomic clock. Now this is a clock 0, so we as users, we cannot connect to that clock to synchronize our time. A network device can be configured as either NTP server or NTP client. So you have to go to the switch, for example, say NTP server. You tell where is the server, where is the IP address of the server. 192.168.1.1, for example, this router, that's the server. Then you say show NTP association. Thank you for watching CCNA day 1, part 1 and part 2. Hopefully see you in day 2. Goodbye.